Oh, there we go. Okay. All right. So indirect measurement with trigonometry. Goal of the day is to be able to use the trigonometric ratios to find the height of an object. Before we get too into it, again, quick review. Within trigonometry, we all know the three sides: opposite, adjacent, and hypotenuse, and our three trig ratios: sine, cosine, and tangent, depending on what side lengths you're working with for your particular problem. We did problems like this at the very beginning of the quarter, or close to the beginning of the quarter, where we were able to use indirect measurement to find the height of an object, but we had this other triangle involved, this one that you knew the triangle. You knew this person's height, you could measure the shadow, you could go measure the shadow, and you could find the height of this tree. And so the way we did that is we said, okay, so like X, the height over 5. Oops, I have 15 there, which is the answer. So pay no attention to that, right? That's equals the shadow of the tree over the shadow of the person. We took the cross product and we got 3x equals 5 times 9 is 45. We divided by 3 and we got x equals 15 and the height is 15. So we were able to find the height of this triangle, but again, it took a second triangle. It took a similar triangle to do it. And what trigonometry does, we've been learning all this trig, is it kind of replaces that tree. It replaces this thing that we needed to know to have ratios that we could use. So today, what we're going to kind of start talking about, exact same problem, but now we don't have a second triangle. Instead, we can use a transit to measure the angle to the top of that item. So to the top of the building, the top of the tree, or the top of the flagpole, or the top of the street lamp, whatever it is, we can use a transit and get what that angle of elevation is, which then allows you to use trigonometry. So I'm going to be, from this angle, I'm looking for the opposite, and I know the adjacent. So that's tangent. And in fact, every problem we do from here on out is going to be tangent, because we're going to be using a transit. We're going to know the distance to the object, and we're going to be looking for the height of the object. So we're always going to know the adjacent. We're always going to be looking for the opposite. So for us, it's going to be the tangent of 59 equals the opposite x over the adjacent 9. And put that over 1. We take the cross product. 1 times x is x equals 9 times the tangent of 59. Switch over to my trusty calculator here. 9 times the tangent of 59. And I get 14.978. And if I round up, that would be 15. And the reason I didn't get exactly 15 is because that angle technically is not exactly 59. It's 59.0 something. All right. So again, these objects might look familiar. We did these when we had similar triangles. We found the height of these objects, and now we're going to find the height of these objects instead by surveying, by using a transit. What's the distance to the object? What's the angle to the top? All right, so we're looking for the opposite side. I know the adjacent side, and I know the angle of elevation is 40 degrees. So we have the tangent of 40 equals the opposite x over the adjacent 20. Take the cross product, 1 times x is x equals 20 times the tangent of 40. Use my calculator. 20 times the tangent of 40, 16.78. 16.78. One thing to kind of, you can always check your answer and think of it if what you did seems to make sense. If this is a 45-degree angle, that means this side and this side are the same height, same length, I should say. The 45 creates a triangle with the two lengths are the same, creates an isosceles triangle, right triangle. As this one starts to get less than 45, it means the opposite is going to be smaller than the adjacent. This is bigger than 45. It means the height is going to be taller than whatever the adjacent is. So that's something, kind of like double check, see if what you did makes sense. All right. Let's see, how many of these do I have? I think this might be the last one. Or do we have one more after that? Last one. Okay. Last one. I'll give people a second. Opposite. And we know the adjacent. Again, every problem today is going to be that exact same setup. So we have the tangent 25 equals the opposite x over the adjacent 30. Take the cross product. 1 times x is x equals 30 times the tangent of 25. X equals 30 times the tangent of 25. And we get 13, if I round up, 14. 14 feet is the height of that lamppost. I'm going to hand out the worksheet. If you feel comfortable, you can just get started. We're doing just the first, just the front side. So I'll do one up here. You can follow along. Otherwise, if you feel comfortable, you can go about. So find the height of this tree. Again, so we're looking for the opposite side, and we know the adjacent. So that's always going to be tangent to these problems. So the tangent of 41 equals the, oh,